Jai Hind to all. My name is Babita. I am an assistant professor in MC department at Ajay Kumar Garg Engineering College, Ghaziabad. So today we are going to discuss the new lecture in the series of IoT, Internet of Things. And this course is derived from a MCA department and the code is BMC043. So basically this lecture is more beneficial for the MCA students. And today's topic is embedded platforms, or you can say the embedded systems. So what is the role and what is the importance of embedded systems in IoT? Let's get discussed with this lecture. Firstly, if I am talking about the IoT revolution, so basically if I am discussing or we are seeing as per the requirement, or you can say in today's era, IoT is becoming more popular technology. So Internet of Things is transforming industries by connecting millions of physical devices from factory floor to the smart home. So basically, how can we understand? Just for example, before this time, we have also the devices like like a washing machine, like lights, bulb, and but the question is arise ki how these ordinary devices becomes the smart devices. So the answer of this question is fulfilled by the concept of the embedded system. So basically the embedded system is the brain of the IoT environment because it provides the capability of sensing, processing and communication of the devices. Yeah, you can say the between the devices, right? So this is possible just because of the embedded platforms. So basically what is this embedded platforms, or you can say what is this embedded systems, we will discuss in this lecture in detail. So embedded system are the backbone of the IoT environment, or you can say the IoT technology, which enables smart devices to communicate, process the data and interact with the cloud. Basically, if I am talking about the IoT stack, it is not the single technology, it is the integration, yeah, you can say the integrated technology in which we are combining or we are merging, yeah, we can say we are integrate more than one technologies together to make the sense of IoT. So they play a critical role in ensuring the seamless functionality of IoT application across the industries. So why it is important? The question is answered. The embedded system are the core, or you can say the heart of the IoT applications, which ensure the efficiency and the connectivity between the devices or the reliability, because it provides the seamless communication between the all physical objects or the smart devices which are integrated or which are connected with together to make the IoT implementation, right? So there are some important tasks which is performed by the embedded systems. First one is the data processing in smart devices. So basically the processing of a data, when we require the data processing, because as you know very well, in a IoT, the most of the things is performed by the sensors. Because if you are connecting a sensors and these sensors collecting data 24/7 hours continuously, so how much, yeah, you can say the huge amount of data we have collect through the sensors in IoT. And what is the important part ki all these collected data, or you can say that this huge amount of data being shared to the cloud. So it is not possible because we have a limited storage space, we have a limited energy. That's why we have the need to share only the important data to the cloud. So we have the need to process their data. So basically data processing is a means to process data. That means we are filtering useful or important insights through the raw data, because data is collecting in a vast amount, or you can say sensors are continuously collecting data, but all the data, yeah, complete data is not useful for all time. That's why we have to process it, right? So for instance, like a smart thermostat analyze temperature uh, uh, of the environments, but this temperature data is collecting every second. So basically we are not working on the every second's data, but we are taking a particular average temperature in a minute, right? So this is the main concept of the data processing. Now we will talk about the efficient communication with cloud. So basically, if I'm talking about the communication, because the communication is between the physical world or the cloud, right? So here sensor and actuators are performing the data collection and data actionable part of the IoT environments. So these systems are using lightweight protocols to communicate with each other. Because why I'm saying the lightweight protocols, because as you know, in a computer network we have a lots of protocols which helps in communication between the devices. But here we have the requirements of a lightweight, because lightweight is required for energy efficiency, to minimize the latency, to minimize the delay, and to maximize the productivity, or you can say the throughput, right? So this is the necessary point, and this is the necessary steps that is carried over by the embedded system, and this is possible just because of the embedded systems, right? Enabling edge computing. What is this edge computing? So basically, if I am understanding this concept, just for take an example, we are seeing atmosphere, yeah, we are looking around your, right? And you have seen lots of things, but you are focusing only a particular object, right? So what is this? This is the edge computing. We are taking another example. Let's say in a traffic management system, lots of traffics are moving around there, but the system is focusing on the obstacle part. So I'm not sharing the whole traffic videos and whole traffic data, but I'm just focusing on the obstacle portion of the traffic, and I'm just sharing this particular data to the system. So this is the edge computing. Edge computing means you are sharing the near about data for the processing, right? So by processing data locally, that means you see the whole videos. Just I'm saying this कि आपको पूरा वीडियो दिख रहा है, उस पूरे वीडियो में आपको और भी बहुत सारे चीजें दिख रही होंगी, या बहुत सारे ट्रैफिक्स आप उसमें ऑब्जर्व कर रहे होंगे, बट आपने कौन से पार्ट पे फोकस किया है? आपने जो डेटा शेयर किया है या डेटा फॉरवर्ड किया है, वो जस्ट उस पार्ट पे किया है जहां ऑब्स्टिकल आया है, राइट? सो दिस इज द लोकल प्रोसेसिंग. And the embedded solution reduce the reliance on cloud computing and improving the response time for ensuring the data, enhancing the data privacy. So this is the main. Next, we will talk about the some popular platforms, embedded platforms, which are most widely used in 2026. So here we are talking about Amazon Web Services. Just we will call as a AWS also, and in which we are talking about the real-time operating system. It is required for sharing the real-time information. If I'm talking about the edge computing, so it is fulfilled by the real-time operating system. Just for example, in a healthcare sector, you have a patient and you want to collect the information about this patient. So there is the required the patient information is at on spot, right? As per the condition of the patient, the system will share the information according to the patient condition. So this is the real time information. And next is a IoT core. So IoT core is also working in this direction, because we have the require of the reliable data and with minimum delay and with minimum latency, and maximum throughput. That's why we are using these type of platforms. Next, in which we are talking about the Microsoft Azure IoT. So these are some popular platforms which are most widely used in today's era if you are working and if you are exploring this concept in detail. So I'm talking about these platforms one by one in my next videos. Here I'm just taking a brief description about the popular embedded system platforms like RI, Veracity and ThinkWorks, Google Cloud IoT and Cisco IoT Cloud Connect, Salesforce IoT Cloud, IBM Wonstein IoT. Most of the students may also heard about these tools and these platforms, but if you don't know, I will discuss in the next slide. Next, I'm talking about the key component of the IoT. We can say embedded IoT platforms. Basically, IoT is a complete sense of the combination of sensors, actuators, cloud and connectivity. So basically here we have a 4 steps, or you can say the 4 main components which are working in the complete the definition of embedded IoT platform. So basically here we have the first step, or you can say the first component of the device management. If I am talking about the device management, so what kind of device we are taking here, we are connecting in a IoT, or the main responsibility of the embedded system which is most popular for the sensing, processing, communication and transmitting. This is the main role of the embedded system, because these system is mainly used for these type of functionality. So here we have the sensors, right? Sensors and actuators. And the core responsibility of the embedded systems is to perform the device management. That means you have lots of sensors, you have lots of actuators, and you have to integrate with each other to make a seamless functionality of the IoT systems, right? Yeah, IoT applications. Next step, or we can say the next component of the embedded platform is connectivity. So basically the role of the connectivity is also considered as a layer of the embedded system conceptual framework, in which we are talking about some connection protocols, right? Yeah, we are talking about some communication technology in which we have a Wi-Fi, right? LoRaWAN, Zigbee, or you can say NFC, right? So lots of technologies are helps to make the connection between these devices and to make the information transfer from one place to another place. Because whenever we are talking about the IoT, that means is mutually understanding. The IoT is a technology in which things are communicate with each other without human intervention, right? There is no human intervention, there is no human is participating in the communication process. The things automatically communicate with each other, things automatically will collect the data, things automatically will perform the action, and things automatically will make the decisions, right? These means all things are getting automatically or working automatically. So this is the main core concept, and this is possible just because we are using as a heart or as a brain of the IoT is embedded system. Next is a data processing and analysis. When sensors and actuators will collect the data, and by using some technology they are able to connect with each others. Now this data which is collected by the sensors and actuators is transferred for the processing. Why it is required? Because as I discussed, sensors continuously collect data, and these data is become a huge amount of data, but not necessary the all data is important for all time. We have a process which one is important. Yeah, you can say the important insights is fetching from the raw data, and this particular data is used for a decision making, right? So next component which is play an important role in the embedded system configuration, that is a data processing and analysis. So now the data is available on a cloud space, right? Or for a some kind of other technology you may call as a AI or ML, which is used to make the decisions for a further processing. Next, last is a security, because every process is incomplete if we are not concerned about the security. So this is very, very important, because as you know, Internet of Things is discussed as the communication between the things by using internet. Or as you know, the internet is an open platform, or anyone can use at any time, anyone can use at anything. So there is the require, you have the mechanism of a security, you have the mechanism to make the your data private, and make provide the reliability on the platform, right? And this is done by the using security mechanism, right? So as we discussed in previous slides, all things or all components which is necessary or which work at these stages are sensor and actuators. The role of the sensor and actuators is to collect and respond to the real world, because as per data collection, the action will perform, and this is done by the actuators. For example, temperature sensor collect the temperature data, motion sensor detect the motion of the objects. It may be moving from one direction to another direction, and other type of sensors may collect the different kinds of information. So whenever we are required that type of functionality, we are using some specific sensors device, right? And next module is the connectivity module, and in which we are talking about the some connection, or you can say the some network technologies which is help to make the communication between the devices, or you can say the things, right? And it will discuss in term of a Wi-Fi, and these particular technology may prefer as per the requirement, as per the range, as per the data availability. So basically, if we have the small infrastructure, or we have the small network, so we are using Wi-Fi or Zigbee, right? If we are talking about the large infrastructure of the IoT application, so we will prefer mainly using LoRa, or you can say the NB-IoT, right? So according to the range, according to the requirement, according to the functionality, we may prefer the technology to make the connection between the devices. Next is a microcontroller, that is also known as a microprocessor. So this microcontroller is nothing but it is a kind of embedded system, and it is also known as the heart or brain of the IoT applications. So the main role of this particular component is a processing of the data, because all things is done through this layer or through this component and execute the task. If we are performing a processing, definitely we are reaching at particular point where we have to take the decisions, right? In which we have most widely used ARM Cortex microcontroller, Arduino microcontroller, Raspberry Pi microcontroller, ESP32 and 8266, right? So lots of microcontrollers we are using to implement that particular scenario. Next we have the component, that is a memory, and memory, you know very well, is very precious component of in the IoT, because we are collecting a data continuously, and this data may be a very huge amount of data. So there is the main requirement to utilize your memory space for better performance, right? So storage, program code and sensor data is required to store on a cloud, or you can say on a memory also. So basically here we are using some different kinds of memory in which we are talking about the EEPROM memory, NOR, NAND and flash memory, right? So according to the better utilization of the memory, we are using different kinds of memory, right? And last one is a operating system, and also called as a firmware. We whenever we are talking about the IoT infrastructure, we have a lots of implementation, and we have a different microcontrollers. So basically that type of microcontrollers require their firmware, right? If I'm using a ESP32, so basically I'm using that firmware, right? If I'm using a Arduino, we have a different firmware, right? So according to the microcontrollers, you will decide the operating system, you will decide the firmware on which you are working, right? So manage devices, resources and run application according to the requirements. So here we have the examples like FreeRTOS, that is a real-time operating system, Zapier and Contiki OS, right? So this is the next in this series. We are talking about some categories of the embedded platforms. Just basically यहाँ हमने डिस्कस किया है कि डिफरेंट टाइप ऑफ कंपोनेंट्स होते हैं, बट दिस इज द मेन कंपोनेंट्स, and this components now classified on some basic criteria, right? So if I am talking about the microcontroller based embedded system, so here we have some other classification, that is a Arduino. So whenever the question is arise, so the Arduino is which type of a microcontroller? So answer is, you are saying this is a microcontroller based embedded platform. So if I'm talking about the ESP8266, so this is also the microcontroller based platform. Here we have the 4 category, in which we have the first category is microcontroller based, second one is a single board computer, third one is a system on a chip, and fourth one is a FPGA based platforms, right? So basically the embedded platforms is classified into 4 category. The first one is a microcontroller. अभी तक अगर मैं ये बात करूं कि स्टूडेंट्स अगर ये पूछा जाए कि what are the different kinds of embedded platforms, they will answer the Arduino board, right, and ESP, Raspberry Pi. But if I am talking about the classification on the basis of characteristics, so here we have the board classification, that is divided by on the basis of functionality, on the basis of configuration, on the basis of specialty, right? So controller based हम बात करेंगे Arduino, ESP8266 and STM32, right? So these are the embedded platforms. It is also known as a hardware platform also, because if I am talking about the embedded system, it is a combination of a hardware and software. So these are the boards which are tangible property, and these boards are known as a hardware components, right? If I am talking about the single board embedded platforms, which is more powerful and capable of running Linux based operating system, most of the you see the work is in a Linux based, because in a Linux you have the compatibility to use a different kinds of command to implement the functions, right, as compared to Windows, right? So here we have the example of Raspberry Pi, BeagleBone and NVIDIA Jeston. So basically these are the platforms which is more specifically used for the Linux operating system, right? And next we will talk about the system on a chip. If I am talking about the specialty of a single board computer, because in which we have some drawbacks. The drawback is that just for example, we have required some kind of functionality. For this functionality, we are using different objects, right? Yeah, different devices externally. But if I am talking about this category of a microcontroller, so all things and all functionality and all components is available on that single board. If I'm talking about the Raspberry Pi, so Raspberry Pi is a very small microcontroller, even you can put into your pocket, and it is also called as a mini computer, right? On a single chip, just like your credit card. On a credit card size, uh, you have the system configuration and you implement everything that you have, you will implement by using a computer. So this is the core functionality of a single board components. And next, this is also the mini as compared to single board. This is a system on a chip platform. That means combine the CPU and memory and connectivity into a single chip. That means the size is become less as compared to this particular category. अब क्या हो रहा है कि आपका जो मतलब सीपीयू है, पहले क्या था, सीपीयू अलग था, बट अब क्या है कि सीपीयू, मेमोरी एंड अदर कनेक्टिविटी components is integrate on this single chip, and this will become ESP32, Qualcomm and Snap ठीक है, sorry, Snapdragon and Nordic NRF52. So these are very many hardware platforms of embedded system which is perform, or which is the functionality of these hardware is better than this particular category, right? So we will discuss in next lecture series in detail, but now we are just taking a brief introduction about these platforms. The last category of is embedded system is FPGA based platform. It is used for high performance custom processing application. If I am talking about the IIoT 4.0 and 5.0, so basically in that type of application you are using that type of hardware platforms, right? So in which we have the most widely used platform is a Intel FPGA board, right? Next, in this slides, we are talking about the challenges for an embedded system in IoT infrastructure, right? So here we have the power consumption, security concern, and integration complexity. If I am talking about the power consumption, so basically, as you know, the sensor device is collecting 24 and 7 hours data, so it will require the more power to consume it. So the lower power designs or lower power devices may require to save the battery life and to ensure the energy efficiency. If I am talking about the security, so basically the protection of a sensitive data and the user privacy is very important. That's why cybersecurity remains is a critical issues and ensuring embedded system, because the most of the functionality is performed by the embedded system, so that the responsibility is taken by this part of the IoT, right? And next is the integration complexity. So basically we are using different kinds of devices, because Internet of Things is a connection of the or connectivity of the things. So basically here we have the different kind of devices, and these devices more comfortable with each other just because of the interoperability. So this is the require, or this may be the challenge, and this is make the solution for this particular. We are using different kinds of protocols, and these protocols make the seamless communication between the devices. Next, we are talking about the application of the embedded system. So the most widely, or we can say the most popular fields where the IoT is very important in a smart home, healthcare sector, and industrial IoT. If I am talking about the smart home, so lots of devices and lots of appliances you are using in a smart home, because as you see, the smart lock, lighting systems are the part of the smart infrastructures. So secure access with smart lock, automating lighting systems may be preferred, and automatically appliances you are using, that's called the smart appliances, and remote monitoring and control. So this is very important just because of embedded systems. Healthcare sector, if we are require the real time data about the patient or the monitoring, so we are using embedded system in term of a wearable devices, right? And industrial IoT, because we are having a business, and these businesses may grow by using some smart machines and smart infrastructure in which human intervention is not required. So predictive maintenance and failure detection is done by the using embedded system. So this is the all about today's lecture, and maybe it will be very helpful for you. Thank you so much.